We've talked about the idea of geometrically representing a circle with an equation and what that concept actually means, i.e. creating a set of points at a set radius from a centre point that allows us to complete a geometric loop, i.e. a geometric circle, and represent what the equation of a circle would be. What I'm going to do in this video, I'm going to give you a couple of questions based on what we talked about in the last video. I want you to pause the video, have a crack at the questions, and then come back and check what you've done against what is here. So here they are. First one is about giving me the equation of a circle with a centre at the origin going through a certain point. The second one is, can you look at the equation, read the information off it, and get the bits that I'm asking for, the centre and the radius. And the last one is a bit more information about a circle. It's not giving you a point, but it's giving you a little bit of information as to something that might help you, a bit of an extrema for the circle. And I want to see if you can find out something else and use it after that. So pause the video just now and have a crack at these questions. So the first question, what's the equation of a circle with the centre of the origin through the point -2, 3? So it's the centre at the origin. Instantly we need to make sure we remember that that's x squared plus y squared equals r squared. So what we need to calculate in this one is the r. Now, think about it again. There's our centre at the origin, there's the point, let's call the point P. To get the radius, we need to figure out the distance between those. So look at the point and figure out how far it's gone. So from 0 to -2, that's a distance of 2. And then from 0 to 3 in the y-axis is a distance of 3. So I can use that to get my r squared to then plug into the equation. From this, I know that r squared is equal to 2 squared plus 3 squared. So r squared is equal to 4 plus 9. So for this equation, r squared is equal to 13. Now remember what we said before, r squared is what we want, not the r, but r squared. So I can just keep it as r squared equals 13 and plug it into here. That then gives me x squared plus y squared equals 13. That there is the equation of this circle, so it's got a centre at the origin and a point -2, 3. So think about it if you were to draw it. It'd be a circle there, the centre is based on the origin, there's the point there, -2, 3. Represent all these points all the way round. Second question, I want you to state the centre and radius of each of these circles with these set equations. Now remember, that's x minus a squared plus y minus b squared equals r squared. And our centre was at the point A, B. So our centre was at the point A, B. Now, in order to get these, what we have to do is look at the information that's here and figure out what we've got. Well, it's x minus a squared. This is x minus 2 squared. So I can just read off that this part here is the a. For the y part, it's y minus b all squared. But in this one, it's y plus 1. So what I can do is think of it as y minus 1 all squared, because it has to be a negative in the middle of the bracket. In that case, I know then that the -1 is equal to my b. So I can read off my centre from that as 2, -1. What I then have to do is figure out my radius. Well, I know the equation is equal to r squared, and in this case it's equal to that, so I know that r squared is equal to 36. So r is equal to the square root of 36. The radius for this one is 6. So I've got a centre at 2, -1, and a radius of 6 for this circle. Second one, x minus 2 squared equals 4 minus y plus 1 squared. Now, this isn't in this form here. It's not in the form we want for the equation of a circle. So I have to do a bit of jiggery-pokery and shift it about. I've got to take all of this part here and shift it across to this side. That then gives me x minus 2 all squared plus the y plus 1 squared equal to 4. Now it's in the form I want. Now I can start to shift it about. So x minus a squared, x minus 2 squared. There's my a. I've got y plus 1. It's the same logic as before. It's got to be a minus. So it's y minus -1. And that there gives you your b. So I can then say, fine, so my centre is going to be located at 2, -1 for this circle. So same centre actually as this circle up here. I want to figure out my radius, so I know the equation equals the r squared. So this part here is my r squared. So I know that r squared is equal to 4. Well, r squared is equal to 4. The radius has to be 2. So there you go. I've got the key bits of information. I've got the centre at 2, -1, and a radius of 2 for this circle. Last one, a circle with a centre of -3, -5 has a tangent at the x-axis. Find the equation of the circle. Find the coordinates where the circle cuts the y-axis. Now, one like this, the best way to do it is to do a sketch. Now imagine we've got the sketch here. It's a centre of -3, -5, so along there and down to there. So there's my -3, -5. And it's got a tangent of the x-axis. So what that means, if I was to draw a radius on, it would touch the x-axis but wouldn't cross it. So my circle would look something like that, just slightly better drawn. So I know that this bit here, that is my radius. So that's what I've got to figure out is my radius. Well, I know this is along to -3, and I've gone down to -5. So if my tangent's along 3 and nothing in y, so my tangent touches there on the x-axis at -3, 0. So to go from there down to 5, I know that the radius has to equal 5, because it goes from there right to the centre. So for part A, I know my radius is equal to 5, and my centre is equal to -3, -5. So there's your A, and there's your B. It's now plugging it into the equation. So I know I've got the equation x minus a squared plus y minus b squared equals r squared. R is 5, so r squared is 25. Plug each of these in. I've got x take away -3 squared plus y take away -5 squared equals the 5 squared. Now you simplify it. You never leave it in this form. I end up with x plus 3 squared plus y plus 5 squared equals 25. So there you go. That's the equation of the circle at once. Part B, find the coordinates where the circle cuts the y-axis. So I'm looking for these points here. Well, I know on the y-axis, x is equal to 0. So if I substitute x equal to 0 in this, I should get an equation that I can solve. So plug it in, and I get 0 plus 3 squared plus y plus 5 squared equals 25. This will give me a quadratic in terms of y when I multiply it out. So let's do that. So I get 9 plus y squared plus 10y plus 25 equals 25. Get it all sorted and make it equal to 0. I get y squared plus 10y plus 9 equals 0. Take this and factorise it, and you get y plus 9, y plus 1 equals 0. So from that, I'm able to tell you that y equals -9 and -1. So what this means is the coordinates where it cuts the y-axis can be given as two coordinates. One of them's at 0, -1, and one of them's at 0, -9. Always, always, always write these in a proper coordinate form with an x and a y. Don't ever miss that out. It's asked for a coordinate, it's not asked for a value. Make sure a coordinate always has the proper format, i.e. an x part and a y part, even if one of them or both of them is 0. We have to be able to do these skills. Just remember that your basic equation for a straight line, always given by this, x minus a squared plus y minus b squared equals r squared. Get each of the parts of it. The a and the b come from the centre, the r is the radius, and you'll have no issue with this bit whatsoever.